Okay, let's take a look at this problem. Longest substring without repeating characters. Given a string, find the length of the longest substring without repeating characters. For example, this string, the longest substring without repeating characters is xyz. If we include in one more character at the left, x is repeating. If we include in one more character at the right, the x is repeating too. This is also a non-repeating substring. If we include in one more character from left, x is repeating. If we include in one more character from right, z is repeating. So the longest substring we ever encounter is xyz with length 3. So how can we systematically find this answer? We can use 2 pointers, use a sliding window. This is a starting pointer, this is the end pointer. Originally, they both pointed to index 0. Now let's recording. The last time we seen a character x is at the index 0. We can use a hash map for that. And the starting index previously pointed to 0. Now let's increase the ending pointer. We encounter another x. So this time, the last time we see the x is at 0, so starting pointer have to be moved over that position in order to remove the x out of the sliding window. So let's move x to S2 pointer to position 1. And again, those 2 pointers meet. The sliding window contains only one character, which is x, which is fine. The longest substring we see is currently have only one character. Now let's move the end pointer one step further. We encounter a y. So let's record its position. And let's move the end pointer one more position. Now we encounter a z. Let's record the position. Let's move the sliding window. Now we encounter x, which already in our hash map. In this case, s need to be moved forward in order to remove that x out of the sliding window. But so far, the longest substring without repeating character is length 3, right? The length 3, and our starting index is at 1. Our ending index is at index 3. Let's recording those positions. And now let's move s across last time we see x. So let's move it forward. And now the x has a new position, which is at index 4. And we again get a non-repeating substring with length 3. The length is not longer than 3, so we don't register those positions. Let's move forward. We encounter a z. So in this case, we get a repeating characters. We need to shrink the sliding window. S need to move to across the last time we see z. Otherwise, we will always include z. So move here won't help because we still have z. So s need to be moved across z. So need to be moved here. Last time we see z is index 3, so s need to be moved to index 4. And again, we get a sliding window, which only have 2 characters, not bigger than our 3. So we just pass it. We move e forward. We find a z already exists. So s need to be moved across the last time we see z, which is should be moved here. And z get an update. We get a 5. And e move forward. We have y, and in this case, there's no repeating, and we move forward. and that's the end. So during the process, the longest non-repeating substring have length 3, starting at 1 and at 3, so we can reconstruct that string. Index 0, 1, so this is our starting index, and index 3, 0, 1, 1, 2, 3, so this is our substring, and our answer is given. XYZ is our substring. So let's take a look at the code. Just as described, we first create a hash map which records the last time we see a character, the index, and our max length is registered as 0. The star index is registered as 0, and actually we don't need that end index if we already have the length, so we only need 2. And the start end both start at the index 0. As long as the end index is not out of the boundary, we keep increase the end index. If the next position already contains the character the end index is pointing to, then we move the start index in order to shrink the sliding window. The start index needs to be moved to the next time we see the need to be moved to the last time we see the current character. So in that case, if the end minus start plus 1, the current sliding window above the maximum length we have seen before, we register that position. And finally, the next position, we store the index is end index plus 1. Okay, so finally we store the word substring star index plus max length, and that is our answer. A little bit different from the description is the next position we store is this is a position we need to move the star index to after we see repeating. So the star index is directly moved to the last time we see the position plus 1. This is where a little bit difference from what I'm described, because I put the next position. This is a position the star index we are going to move to, and this is a code.